Hello children. Today's topic which we will be covering is acceleration and retardation. I hope everyone is clear with what is actually velocity, right? We discussed that velocity, okay? We said that velocity is nothing but we can say that it's the distance traveled per second by the body in a specified direction, right? Or we said it's the rate of the change of displacement of a body with time, which is called as velocity. In velocity, we discussed what is actually uniform velocity, non-uniform or variable velocity, instantaneous velocity, average velocity, and also we distinguished between two different things, that's speed and velocity. How speed and velocity are two different things, right? We said velocity is change of the displacement per unit time, right? There is a change in displacement of the body with the time, with the time we say that it is called as velocity. Now today the things which we are going to focus is nothing but acceleration. Okay, now we had given an example about uniform velocity. Okay, when we were talking about uniform velocity, I had explained you that when we say that a particular body is in uniform velocity, so we say that a body is traveling equal distances in particular direction in equal intervals of time, then we say that the body is in uniform velocity. That means it has to travel equal distances in equal intervals of time as well as in that same direction. However, bodies generally don't move with uniform velocity. It's a very rare cases. So velocity of the body will always it will be keeping on changing. So if the velocity of the body changes, okay, if the velocity of the body changes, it can change because of its magnitude, it can change because of its direction, or else it can change because of the magnitude or the direction. If velocity of the body is changing, okay, it changes because of the magnitude, because of the direction, because of the magnitude or direction. I had explained you the three cases, if you remember, that how there can be non-uniform velocity. You did remember, right? Unequal distances, then the direction. This I had explained you that how it can be non-uniform or variable velocity will be there. Then motion of the planet which is around, that is the motion of the planet or satellite, it's called as variable velocity because it's always changing its direction, right? The direction is changing in this, so we say motion of the planet or the satellite is variable velocity. So before proceeding to acceleration, first you understand what is variable velocity. Then example is given as the motion of a vehicle in a busy market or while leaving or approaching a destination, okay, or a vehicle in a busy market or while leaving or approaching a destination is variable velocity. Then the motion of a planet or satellite in a circular path is also an example of is also with variable velocity. Okay, now let us consider a body. Okay, let us consider a body A I have drawn over here. So this body A which is there, it's moving in a straight line, so there is no change in the direction. Okay, change in the direction, no change in direction, that means it is moving towards the east only. But there will be a change in the speed, right? There will always be a change in the speed even if the body is moving in a straight line. Look at this, body is moving in a straight line, say it's moving towards the east, there is no change in the direction but there is a change in the speed. How there will be a change in the speed? For example, if you are riding a bike, okay, or you are sitting on the scooty with your mother, okay, behind, or your father, then you will observe that when there is a busy road, okay, they will be going little slower, and when there is the road is clear, he will be taking, or your mother or your father, they will be taking it at a high speed. So when they will be taking at a high speed, always they will be accelerating the handle wherever it is, right? So they will be increasing the speed. So if the velocity of the body will be increasing with the time, right, the velocity will be increasing. Okay, that means magnitude, they are traveling over here, there is a specific direction, so velocity of the body will increase with time. So when the velocity of the body increases with time, when the body is traveling in a straight line, motion is said to be accelerated. I hope you are understanding what I mean. Okay, so when the body is moving in a straight path, there is no change in the direction but there is a change in the speed. Okay, so in such case what will happen? The velocity of the body will increase with time. If the velocity of the body increases with time, then what happens? The motion is accelerated. The motion is accelerated. Accelerated means little, there is an increase. There is an increase in the motion. The motion is increased, accelerated. And if the velocity of the body decreases, right, now there is, after traveling in a smooth road, after traveling in a very, nobody on the road and you are going fast, suddenly you enter a busy road. So what happens? You slow down your speed of the bike. Once you slow down the speed of your bike, the motion velocity of your body decreases. Velocity of the body decreases. So what happens over here? The motion is decelerated or retarded or negative acceleration. Once again I will tell you, if the velocity of the body decreases from the uncrowded road, you came to a crowded or a busy road, the vehicle's velocity has decreased. So what happens? Motion is decelerated or retarded, or we call it as negative acceleration. Here when we say, this is called as the positive acceleration and this is the negative acceleration. Now I will explain you these terms, but I hope that it is clear what is actually velocity of the body, how the motion is accelerated or how the motion is decelerated. Then from this we will say that acceleration is nothing but rate of change of velocity with time. Okay, it's the rate of change of velocity. So change in velocity upon time gives me the acceleration. So if the vehicle is moving in a straight line, there is a change in the velocity. Okay, and when there is a change in the velocity, it's with respect to time. So change in velocity, rate of change of velocity is given upon time is called as acceleration. The SI unit of acceleration, we will derive it. SI unit of acceleration. What is the unit for velocity? The unit for velocity is meter per second. What is the unit of time? Second. So per meter per second, ms raised to minus 1 upon s, which is nothing but ms raised to minus 1. Now this second has value 1. So when it goes up, it becomes minus 1. Okay, so ms raised to minus 1 minus 2, so ms raised to minus 2. So the SI unit of acceleration is meter per second square. Meter per second square is the SI unit of acceleration. It's the SI unit of acceleration. Okay, so here CGS unit of acceleration is centimeter per second square. CGS unit is centimeter per second square. I hope acceleration is clear with you. It's the rate of the change of the velocity with time. Okay, always the velocity will be changing. Okay, rate of change of velocity with the time is called as acceleration. Now here there is a relation for acceleration. So let us consider that this is a body O. Okay, say A is this body. Body A is moving in a straight line. Okay, the body A which is there, it's moving in a straight line. So here if you see, the body has initial velocity u and final velocity v. That means this body is traveling in a fixed direction with initial velocity as u, which is given here, and final velocity as v. Okay, now I have just given the arrow sign. Even if you don't give, no problem. So here they are traveling, this body A is traveling in particular time t from u to v. So what will be the change in the velocity? What will be the change in the velocity from u to v it is going? So change in the velocity will be nothing but v minus u. Okay, v minus u, this will be the change in the velocity. Okay, and then what is time? Time is nothing but t. T is the time given. So here we will say acceleration is nothing but, what is the formula? Change in velocity upon time, which is nothing but A equals to, A is the symbol given for acceleration. For acceleration we give symbol A. A is equal to v minus u upon t. Change in the velocity upon time, v minus u upon t. So from this we say v is nothing but u plus at. Okay, this is a derivation when we will be learning about laws of motion, which we will be studying. So this is the first law, v equals to u plus at, kinematic equations. Okay, these are the kinematic equations which are there. So v equals to u plus at. Okay, so this is the kinematic equation given. So we have got a equal to v minus u upon t. So v is equal to u plus at. Okay, now another thing which they have given is, when the final velocity v is greater than u, then a is positive, acceleration is positive. Okay, when, I hope this is clear how we got this. Body A moving from u to v in a straight line. Okay, it's moving from v to u to v in a particular straight line. Okay, then the change in the velocity. What is the change in the velocity given as? V minus u upon t. Okay, change in the velocity is given by v minus u, which is v minus u. Time is t, so v minus u upon t, which is given, we will be writing over here, which is u plus at. If the final velocity is greater than u, okay, then a is positive, and if the initial velocity is greater than final velocity, then A is negative. So let us see example I have given here. For example, final velocity is 10, okay, whatever 10 meter per second. Initial velocity was 0 meter per second. Okay, so what is the formula? Change in the velocity upon time. Change in velocity upon time gives me what? Acceleration. So 10 is final velocity, 0 initial, 10 minus 0 upon t. What was the time taken? 1 second. So 10 upon 1, which gives me 10 meter per second square. Okay, so this is the case when what? When final velocity is greater than initial velocity. That time the acceleration is positive. Now see here the final velocity. Final velocity is 5. Okay, sorry, minus 5. Initial velocity is 10. Initial velocity is 10, final velocity is minus 5. So change in velocity, final velocity minus the initial velocity. So minus 5 minus 10, minus minus plus, minus 5 plus 10 upon 2, which is minus 5 upon 2. So answer comes as minus 2.5. Okay, answer comes as minus 2.5. Minus 2.5 meter per second square. So when is this case? This case occurs when we say initial velocity is greater than final velocity. What was the initial velocity here? 10. What was the final velocity here? Minus 5. So here in this case the acceleration will be negative. Okay, the acceleration will be negative. Same way they have given an example over here in your textbook. You will see that also. Suppose a car is initially at rest on starting acquires a velocity 20 meter per second in 10 seconds. The change in velocity is given by 20 minus 0, which is 20. Okay, and this change has been brought in 10 seconds. So 20 upon 10, 2 meter per second square. So you can see 20 minus 0 upon 10, so 2 meter per second square. Then if a car initially moving with a velocity 25 meter per second is brought to rest, okay, and it is applying the brakes. So what is here? Can you see here? The initial velocity is 0 here, final velocity is 25 here. Here we can say that the car is initially moving with a velocity. So initial velocity will be 25 here. Final velocity will be 0 because it is coming at rest, it is stopping. Once again I will say initial velocity will be 25 because the car is already traveling with a certain velocity and suddenly it is applying brakes when it comes to rest. So when it comes to rest it will be 0. So we can say that initial velocity 25, final velocity 0. So 0 minus 25 gives me minus 25 upon 5 seconds, which is minus 5 meter per second square, which is retardation, okay, or negative acceleration. Okay, are you understanding what they are giving? The second example, I'll just tell you how it is. Suppose this is the car, it was traveling with a velocity of 25 meter per second. Okay, and suddenly, say for example, there was a tree in between and it stopped. So when this car stopped over here, for example, okay, when this car stopped over here, what was its velocity now? 0 meter per second. So what will be the initial velocity here? 25. So initial velocity will be 25 meter per second. And what will be the final velocity? 0 meter per second. So what is change in velocity? What is acceleration? Change in velocity upon time, which is v minus u. So 0 minus 25 upon 5, which gave the answer as minus 5 meter per second square. So I hope you understood. We have got a negative acceleration. Why we got a negative acceleration? Because the velocity was decreased, so it was retarded, or we call it as negative acceleration. So we can say acceleration is a vector quantity represented by a small a with an arrow on the top. Now here the direction of acceleration is the direction of the change in velocity. For the motion in straight line, acceleration is in direction of motion. So if there is a straight line motion, the acceleration will be in this direction of motion. Okay, now there is another thing that we said that acceleration can be negative, positive, and velocity can also be negative, positive. But there is a difference. Okay, when can velocity be positive or negative? When it is dependent on the direction. Okay, it's all dependent on the direction whether it is positive or negative. But in acceleration it can be positive or negative depending upon whether the velocity is increased or decreased, whether the velocity is increased or decreased. One more example I can give, you are riding a cycle, okay, you are riding the cycle in this direction, okay, suddenly some person comes here, okay, you are riding with a certain velocity and suddenly a person comes here. What do? You apply brakes, okay. Once you apply brakes, what has happened over here? You have given a negative acceleration, right? You have given a negative acceleration. How a negative acceleration? Your speed velocity was more, suddenly decreased. So what happened? Negative acceleration. After this person went, you took your cycle and the road was fully nice, clear. So you're riding, you're increasing. So what is happening? You're just accelerating your cycle by just increasing the speed. I hope these two aspects are clear, what is negative, what is positive. Now uniform acceleration means change in the velocity is not same in the same interval of time. Uniform acceleration is equal changes in velocity that takes place in equal intervals of time. Equal changes in velocity which takes place in equal intervals of time gives me the uniform acceleration. That's a freely falling body. Okay, equal changes in velocity. No, there is no increase or there is no decrease in the velocity. Just equal changes in the velocity. Variable acceleration, changes in velocity is not same in the same interval of time. Acceleration is variable. So example, motion of the vehicle on a hilly or a crowded road. Okay, so we are always traveling our bike in when it's the road is crowded, we are traveling, okay, in variable acceleration or in variable velocity. Okay, I hope this is clear. Then the next aspect which we will be doing is acceleration due to gravity. Very important point of this acceleration. Now what is actually acceleration due to gravity? Now if you see here I have drawn a small little body over here. Say it's body A, okay, it is a freely falling body, it is falling towards the gravity. So when a body falls towards the gravity, okay, an acceleration which is produced due to the earth's gravitational pull, okay, the acceleration which is produced due to the earth's gravitational pull is called as acceleration due to gravity. So now you must be sitting somewhere, so you are having a gravitational pull, right? If you just drop a ball down, okay, the ball will obviously go down, right? Why? This motion will be accelerated by what? By the acceleration due to gravity. So when a body falls under the gravity, okay, when the body falls under gravity, acceleration is produced, okay, due to earth's gravitational attraction, and this is called as acceleration due to gravity. Okay, acceleration due to gravity is generally denoted by the small g. It's given by the letter small g. So now when a body falls down, so let us see what happens. Okay, when a body is falling down, okay, this body is falling down, what's happening to the velocity? Velocity is increasing with time. Velocity is increasing with time. Okay, so what happens if the velocity is increasing with time? So here we can see the body falling down, velocity increasing with time. If the velocity increases with time, acceleration is positive or it is given by plus g. Okay, once again, this is body A which is falling down towards the earth's gravity. Its velocity is keeping on increasing. There is a change in velocity. Velocity increases with time. So what happens? Acceleration is positive, right? Acceleration will be positive. Why? Because it is traveling towards the gravitational force. But now when the body is moving upwards, so this way, like this, when it is moving upwards, I've thrown a ball upwards, okay, so here what happens? The velocity will keep on decreasing, yes or no? When the ball is thrown up, slowly it will decrease, and finally at one point it becomes zero, right? We had learned this in potential and kinetic energy, and then it falls down again. So when I'm throwing it up, velocity decreases with time. Acceleration becomes negative. Why? Because it is against the gravity. Acceleration becomes negative because it's against. So acceleration due to gravity can be plus g. When the body falls, velocity increases with time, so acceleration will be positive. And when can it be negative? When the body is moving upwards, velocity decreases with time, acceleration becomes negative. So we say the value of g is 9.8 meter per second square. But there are some cases that the value of g is maximum at the poles and minimum at the equator. Now the reason for this is there because the gravitational pull which is there, it is maximum at the poles and it decreases as it comes down to the equator. Now here poles are very close to the center of the earth. Now this all has to be this all you will be studying in magnetism lesson. Actually, why does this gravity is maximum at the poles, but for now you just understand, because gravitational pull is maximum at the poles and it keeps on decreasing as it comes down to the equator. Value of G decreases with altitude. Why? Because it is going upwards, like, right, it is going upwards, so the value of G will keep on decreasing, and also at the depth of the earth's surface. Now here they have given us few points that if a body falls freely under gravity, its velocity is increasing at the rate of what? 9.8 meter per second square when the body is falling downwards. So then in 2 seconds what will be that velocity? That is 9.8 into 2, which will be 19.6. At 3 seconds what it will be? So 9.8 into 3, which will be 29.4 meter per second, and so on. At 4 seconds what it will be? So like that, when the body is falling downwards, what is happening to the velocity? Velocity is increasing, right? So the value of gravitation, okay, the value of gravity is also increasing at the rate of 9.8 in particular time period, okay. But if it is going upwards, if the particular body is moving upwards, then what will happen? First it will be 49, then 39.2. so how are we getting this? We are just minusing that 9.8 with it, okay. We are this with this I minus 9.8, with this I minus 19.6, like that, and here 29.4. so this is how what happens when it is decreasing, okay. 49, how did I get? It's at the level, at this level, after 1 second, whatever is the value over here. So this is how its velocity becomes 19.6. so at 1 second 49, at 2 seconds 39.2, 3 seconds 29.4, at 4 seconds 19.6. so this is how the velocity keeps on decreasing when it is going upwards, okay. I hope that these aspects are clear, as well as the value of G. Note, very important thing, the value of G does not depend on the mass of the body. However, if two bodies, that means gravitational G value does not depend on the mass of the body. If two bodies are there of different masses and they are simultaneously dropped from the height, both will reach the ground simultaneously in vacuum. Why? Because there is no effect of friction, buoyancy due to air. So if two bodies are there of different masses and then they are thrown from up, okay, they are dropped down, they both will be having the same effect, okay. They will reach the ground simultaneously at the same time. There will be no effect on their masses, I mean nothing, gravity is not dependent on the masses, and no effect of friction and buoyancy due to the air. And the last point which is there on the earth's surface, I explained you what it is, okay. I hope these points are clear with you, that when the body is falling, okay, under gravity, first it will be 9.8, okay, 9.8, then 19.6, 29.4, after and so on. When it is coming down, when it is going up, say for example 49 meter per second, just an example is taken, 49 meter, 39.2, 29.4, 19.6, like that it will keep on, 9.8, like that it will keep on, what we can say, decreasing here. I hope you understood this, what I am actually speaking. So here we are done with acceleration. Please go through the video once again properly. Acceleration is change in the velocity per time upon time interval. I explained you what is positive acceleration, what is negative acceleration, as well as I explained you that how these parts we get, how acceleration is vector quantity, how acceleration can be positive or negative, okay. Both are two different things. Velocity as well as acceleration's positiveness and negativities are two different things. What is actually acceleration due to gravity? So all this, just go through it, as well as do complete the notes of lesson number 1. Now next session we will be doing the numericals, okay. Next session we are supposed to do the numericals on exercise 2A, okay. Thank you so much children, and take care of yourself.